When changing an electrical service and dealing with a generator power transfer switch, several factors must be considered to ensure code compliance and safe operation. Firstly, addressing the connection of the transfer switch to the outside panel, it is permissible to run the line and load conductors from the outside panel to an appropriately sized junction box inside the building. This junction box will serve as the connection point to the conductors from the transfer switch. National Electrical Code Article 408.35 C supports this practice, provided the junction box is adequately sized and the wiring is properly spliced and terminated. Proper splicing and termination are important to maintain the integrity of the electrical connections and prevent overheating or arcing. Secondly, regarding the generator connection, the transfer switch should ideally incorporate a neutral bonding terminal. This terminal plays a crucial role when the generator's neutral is bonded to its frame. If the transfer switch lacks this neutral bonding terminal, its suitability for use with a generator featuring a bonded neutral becomes questionable. The absence of this terminal can lead to code non-compliance. Considering National Electrical Code compliance, a generator transfer switch lacking a neutral bonding terminal may not fully adhere to code requirements. While National Electrical Code Article 250.20, the FBN number 1 does not explicitly define whether a generator with a bonded neutral constitutes a separately derived system, National Electrical Code Article 250.20. And mandates that the neutral of a separately derived system must be isolated from the premises wiring system neutral. If the generator's neutral is bonded to its frame and the transfer switch lacks a neutral bonding terminal, this isolation will not occur. In such scenarios, there are a few options. Firstly, contact the transfer switch manufacturer to ascertain its code compliance and suitability for generators with bonded neutrals. Secondly, if the existing transfer switch fails to meet code requirements, exploring alternative, compliant options is advisable. Thirdly, clearly articulate the code requirements to the customer, providing supporting documentation to validate the recommendations. Now let's delve deeper into the technical aspects. Understanding separately derived systems and neutral bonding is very important. A separately derived system is an electrical power source, such as a generator, that is not electrically connected to the building's main service. In a separately derived system, the neutral conductor must be isolated from the grounding system. This is to prevent unwanted neutral currents from flowing through the grounding system, which can cause electrical noise and potentially create safety hazards. Neutral bonding refers to the practice of connecting the neutral conductor to the grounding system at a single point. This is typically done at the service entrance or at the separately derived system. In a generator with a bonded neutral, the neutral conductor is connected to the generator frame. This is a common practice for portable generators, as it provides a path for fault current to flow back to the generator, which helps to trip the overcurrent protection device. When connecting a generator with a bonded neutral to a building's electrical system, it is important to ensure that the neutral is not bonded at more than one point. This can create a parallel path for neutral current, which can overload the neutral conductor and potentially cause a fire. The NEC provides specific requirements for grounding and bonding separately derived systems. These requirements are designed to ensure that the electrical system is safe and reliable. Now, let's talk more about transfer switches. A transfer switch is a device that allows you to switch between two different power sources. In the context of a generator system, the transfer switch allows you to switch between the utility power and the generator power. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between the two power sources. An automatic transfer switch automatically switches to the generator power when the utility power fails. Transfer switches are rated for the maximum amount of current that they can handle. It is important to select a transfer switch that is rated for the size of the generator and the building's electrical load. Transfer switches also have different features, such as load shedding and surge protection. Load shedding allows you to prioritize which circuits are powered by the generator. Surge protection protects the building's electrical system from voltage spikes. Understanding NEC Article 250 is critical. NEC Article 250 covers the requirements for grounding and bonding electrical systems. This article is essential for ensuring the safety and reliability of electrical systems. Some key points of National Electrical Code Article 250 include: firstly, all electrical systems must be grounded. Secondly, the grounding system must be effective. Thirdly, the grounding system must be properly sized. Fourthly, the grounding system must be properly installed. Fifthly, separately derived systems must be grounded in accordance with specific requirements. Now let's discuss the importance of proper wiring techniques. Proper wiring techniques are essential for ensuring the safety and reliability of electrical systems. Some key points of proper wiring techniques include: firstly, use the correct wire size for the circuit. Secondly, make sure all connections are tight and secure. Thirdly, protect wires from physical damage. Fourthly, use the correct type of conduit for the application. Fifthly, follow the NEC requirements for wiring methods. Now let's elaborate on splicing techniques. When splicing wires, it is important to use a method that provides a secure and reliable connection. Some common splicing methods include: firstly, wire nuts. Secondly, crimp connectors. Thirdly, solder. Wire nuts are a common and convenient way to splice wires. However, it is important to select the correct size wire nut for the number and size of the wires being spliced. Crimp connectors provide a more secure connection than wire nuts. Crimp connectors are available in a variety of sizes and types. Soldering provides the most secure connection, but it requires more skill and equipment. Soldering is typically used for critical connections or in applications where vibration is a concern. Conduit selection and installation is another important aspect. Conduit is used to protect wires from physical damage and to provide a path for wires to be run. There are different types of conduit available, each with its own advantages and disadvantages. Some common types of conduit include: firstly, rigid metal conduit or RMC. Secondly, intermediate metal conduit or IMC. Thirdly, electrical metallic tubing or EMT. Fourthly, flexible metal conduit or FMC. Rigid metal conduit is the most durable type of conduit. It is typically used in areas where the wires are subject to physical damage. Intermediate metal conduit is a lighter weight version of rigid metal conduit. It is typically used in areas where the wires are not subject to severe physical damage. Electrical metallic tubing is the most common type of conduit. It is lightweight and easy to install. Flexible metal conduit is used to connect equipment that is subject to vibration or movement. Proper junction box sizing is also critical. When installing junction boxes, it is important to select the correct size junction box for the number and size of the wires being installed. The NEC provides specific requirements for junction box sizing. The size of the junction box is determined by the number of conductors that enter the box, the size of the conductors, and the number of devices, such as splices or terminals, that are located in the box. Now, let's talk about grounding electrode systems. A grounding electrode system is a system of interconnected grounding electrodes that are used to provide a low impedance path to ground for fault current. The grounding electrode system is an essential part of the electrical system, as it helps to protect people and equipment from electrical shock. Some common types of grounding electrodes include: firstly, ground rods. Secondly, ground plates. Thirdly, metal water pipes. Fourthly, concrete encased electrodes. Ground rods are the most common type of grounding electrode. They are typically made of copper or copper-clad steel. Ground plates are typically made of copper or steel. Metal water pipes can be used as grounding electrodes if they meet certain requirements. Concrete encased electrodes are typically used in new construction. Next, overcurrent protection is another critical topic. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are an essential part of the electrical system, as they help to prevent fires and electrical shock. It is important to select the correct size overcurrent protection device for the circuit being protected. The size of the overcurrent protection device is determined by the ampacity of the conductors in the circuit. Now let's talk about bonding jumpers. Bonding jumpers are used to connect metal parts of the electrical system together to create a low impedance path for fault current. Bonding jumpers are an essential part of the electrical system, as they help to protect people and equipment from electrical shock. Bonding jumpers are typically made of copper or aluminum wire. Now, let's move on to surge protection. Surge protection devices are used to protect electrical equipment from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, or other electrical disturbances. Surge protection devices are an essential part of the electrical system, as they help to protect sensitive electronic equipment from damage. Surge protection devices are available in a variety of types, including whole-house surge protectors and point-of-view surge protectors. Next, let's look at National Electrical Code Article 310. National Electrical Code Article 310 covers the requirements for conductors for general wiring. This article provides information on the ampacity of conductors, the types of insulation that are permitted, and the installation requirements for conductors. Now, let's briefly cover National Electrical Code Article 408. National Electrical Code Article 408 covers the requirements for switchboards and panel boards. This article provides information on the construction, installation, and wiring of switchboards and panel boards. Understanding voltage drop is also important. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Voltage drop can cause equipment to malfunction or not operate properly. The NEC provides recommendations for voltage drop in branch circuits and feeders. Now let's look at electrical safety. Electrical safety is of paramount importance when working with electrical systems. It is essential to follow all safety precautions to prevent electrical shock and fires. Some key electrical safety tips include: firstly, always to energize the circuit before working on it. Secondly, use insulated tools. Thirdly, wear appropriate personal protective equipment. Fourthly, never work on electrical equipment when you are wet or standing in water. Fifthly, inspect electrical equipment regularly for damage. Now let's talk about using a multimeter. A multimeter is a versatile test instrument that can be used to measure voltage, current, resistance, and other electrical parameters. A multimeter is an essential tool for any electrician or electrical technician. It is important to know how to use a multimeter safely and effectively. Finally, let's briefly discuss troubleshooting electrical circuits. Troubleshooting electrical circuits involves identifying and correcting problems in electrical circuits. Troubleshooting can be a challenging task, but it is an essential skill for any electrician or electrical technician. Some common troubleshooting techniques include: firstly, visual inspection. Secondly, voltage testing. Thirdly, continuity testing. Fourthly, resistance testing. In conclusion, working with generator transfer switches and ensuring NEC compliance requires a thorough understanding of electrical codes, wiring techniques, and safety practices. By following the recommendations outlined in this narration, you can ensure that the generator system is installed safely and reliably.